Let's prepare on the earth pressure of soil. So before going into the earth pressure, first let us see about the retaining walls, because in retaining walls only this term earth pressure comes. So retaining walls is nothing but it is just a wall like structure used to retain a soil or to just hold the soil back. So it is normally constructed along the sides of the bunds or sides of the lakes and all. They'll be using this retaining walls. Okay, so there are different types of retaining walls. The first one is the gravity wall. So gravity wall is nothing but it is just like a wall like structure, so that it just obstructs or it just holds the soil in one side. And the next is the RCC cantilever retaining wall. So it has a cantilever slab like thing at the bottom, so that the holding capacity will be more for this type of retaining wall. So this type is gone bare, means if the height of the retained soil is above 6 meter, means we will be going for this type of retaining wall. So here they tell that the moment that is occurring here, no, so it is directly proportional to the cube of the height of that retaining wall. So in general they have given this example, that is if the height of this is 6 meter, means it is moment will be 216 kilonewton meter, like that we can tell it. And then the third type is RCC counterfort retaining wall. So here this type of retaining wall has to be constructed if the height is greater than 6 meter. Okay, so this looks as a T-beam. So here in the cantilever retaining wall we saw just one slab in this one side, no? So here there will be another thing also like T-like structure. So in this T-like structure, the shorter thing will be called as toe slab and the longer thing will be called as heel slab. So it will be like this. Okay, so this will be your heel slab and this will be your toe slab, and this straight part, no, so that they will call it as the stem of the retaining wall. So this is designed as a T-beam and it is a continuous slab. So here you are having this structures, no, like small supports. So these are the counterforts that is constructed regularly or continuously along the length of the retaining wall. So here this will be in the side of the backfill, that is soil will be in this side only, and in the other side it will be having water or it can be empty also. The next method or the next type is the buttress retaining wall. So here it is designed as a rectangular beam. It is also similar to the counterfort retaining wall, but the only change or only difference is what means here the counterforts or the slabs we saw it in the side of the backfill, no, that is in the side of the heel slab, no. In this case it will be in the opposite direction, that is in the toe side only the slabs or that buttress walls will be there, and that side only it will be empty or having the water. So it is just a opposite structure here. So you can see the supports are provided towards toe, whereas in the counterfort it is provided towards the heel slab. So next we are going into the earth pressure. So the coefficient of earth pressure is a term used here. So it is denoted as K, which is equal to sigma H by sigma V. So it is nothing but the horizontal stress, that is sigma H, and the vertical stress, that is sigma V. So this is considered in the soil that is retained in the retaining wall. Okay, so at rest, so there are three conditions: at rest, at active pressure, and at passive pressure. Like that, three conditions are there. So first let us see at rest. So at rest what happens means there will be stationary, the retaining wall will be stationary only, and there will be no lateral movements in it, so that there will be no yielding in the soil mass also. So the condition is elastic equilibrium, that is sigma H will be equal to sigma V. So both the stresses will be equal, so that it will be in a stable position. So here K is denoted as K naught, which is equal to mu by 1 minus mu. So mu is nothing but the Poisson's ratio of the soil mass, and which is equal to 1 minus sin phi. And the next comes the active pressure. So the active pressure will be a least pressure than the pressure at rest. So here plastic equilibrium occurs, that is the retaining wall moves away from the backfill. Okay, so if this is the retaining wall and here the backfills are there, means it will move away from the backfill. So here the tension occurs, so the yield is happening due to the tension. So let us see how this happens. So I told you, so this is the retaining wall and this is the backfill area. Okay, so here the sigma V will be greater than sigma H. That is, the vertical stress will be more than the horizontal stress. So when the vertical stress is more, the failure is on downwards only, and also this structure, it moves away from the backfill. That is, the retaining wall moves away from the backfill. So these 3 points are very important. So you should know these 3 points in the case of active pressure and also in the passive pressure. That is, vertical stress is more here, and then the failure always occurs downwards, and then the retaining wall moves away from the backfill. So these 3 you should be known of. So here K is mentioned as Ka, which is equal to 1 minus sin phi by 1 plus sin phi, and the inclination plane, that is the failure plane, so it is 45 plus 5 by 2. The angle is 45 degree plus 5 by 2. The next one is the passive pressure. So here it is a plastic equilibrium only, and the retaining wall moves towards backfill. So in the previous case it is away from the backfill, in here it is towards the backfill, and the yield is due to compression, where there it is due to tension, and there the failure is downwards, here the failure is upwards. So these points are very important. Okay, so here the sigma H is greater than sigma V. So in this direction or in this direction, sigma H will be greater than the sigma V. Okay, so when the horizontal action is greater, the failure will be upwards, and also the retaining wall moves towards the backfill only. So here it is represented as Kp, which is equal to 1 plus sin phi by 1 minus sin phi, which is another opposite or the inverse of that Ka, because in the Ka we saw it is 1 minus sin phi by 1 plus sin phi, and in the inclination plane also it is 45 minus 5 by 2, where there it is 45 plus 5 by 2. So when you compare these both and study, it will be clear. So in these points, so these 4 points are very important, so they will be asking any objective from these concepts. And here the relation between the pressure and the coefficient of earth pressure is given. So as I told before, the active pressure will be lesser than the pressure at rest, and which is lesser than the passive pressure. And in the case of the coefficient of earth pressure also, it is same only. Ka is less than K0 and K0 is less than Kp. So here K0 also, it is at rest. So normally for bridge abutments the case is at rest only, and for retaining walls normally it is at the active pressure, and for sheet piles it is normally at passive pressure. Then comes the analysis of earth pressure. So here analysis, there are various analysis methods used here. So the first one is the Rankine's theory. So Rankine's theory, there are some assumptions. So this is also important. So they consider the soil is homogeneous, dry and cohesion less soil, and the ground is horizontal or inclined, and the retaining wall is smooth and vertical. So this is important. And then plastic equilibrium occurs here. And also they define K is equal to tan square 45 minus 5 by 2, and Ka into Kp is equal to 1. So this we saw already, Kp is the inverse of Ka, so obviously in multiplying we will be getting 1 only. So the next one is the effect of cohesion. So here the passive pressure and active pressure is given in terms of the cohesion. So here Ka sigma V minus 2C root Ka, and Kp sigma V plus 2C root Kp. So they will be asking such questions, that is, with what terms of cohesion does the active pressure or passive pressure gets affected, like this they will be asking. Okay, so you should answer like this, that is, if the effect of cohesion is to increase, then the passive pressure will be increasing. That is, due to cohesion the passive pressure will be increasing, and due to cohesion the passive pressure will be decreasing, because here minus, here plus is there. The next is the tension crack depth. So it is defined as ZC. So what is this tension crack depth means? So because of the negative pressure, a tension crack will be occurring in the soil. So where it occurs means it occurs near the top of the wall at a depth of ZC. So this depth is only, we call it as the tension crack depth, which is equal to 2C by gamma root Ka, or 2C by gamma into tan alpha F. Okay, so here the next term is HC, that is critical height. So it is also related to this only. So up to which height we can excavate the soil without support. So if we are doing excavation without a support means at certain point sliding of the soil happens, no? So up to that point is only called as the critical height, so which is equal to 4c by gamma root Ka. So if you compare these both, you can write it as 2 into Zc. And then for clays, we know that phi is equal to 0. So what is Ka? It is 1 minus sin phi by 1 plus sin phi. So as phi is equal to 0, that whole term will become 1 only. So we can neglect that root Ka. So they have given us 4c by gamma alone. The next method or the next theory is the Coulomb's wedge theory. So here the assumptions are the soil is homogeneous, dry and cohesionless. The retaining wall is rough. Whereas in the previous, that is the Rankine's theory, there we assumed the retaining wall is smooth. But here it is rough. Okay, so these are important points. Then the lateral pressure acts as an angle of del. So these del values are very important in this Coulomb wedge theory. So for different cases the del values are given, so you should study this. That is for smooth walls it is 5 by 3. For retaining wall and concrete walls it is 2 5 by 3. So which is a Tersagi's value. And then a backfill subjected to vibration means it is 0, and for rough walls it is 3 del by 3 5 by 4. And then the Ka and Kp formula is given based on this Coulomb's wedge theory. So here it is cos beta into cos beta minus root of cos square beta minus cos square phi by cos beta plus root of cos square beta minus cos square phi. So this formulas will not be asked for calculation purpose. So they may ask sometimes the direct formula is the objective question. So here this minus and plus symbol is alone changed in the case of this Kp. And then there are 3 other methods, that is Rabin's method, Kalman's method and Poncelet method. So these 3 are graphical method. They are also based on the Coulomb theory only. Okay, so this Rabin's method, so the outcome of this is only this Poncelet method. So these both are same only. Thank you and keep watching for the next lecture on stability of slopes.